On November 23rd, something happened in the astronomy community that immediately sent ripples through every observatory and research group watching 3I Atlas. Harvard astrophysicist Avi Loeb released brand new data, and with it, the confirmation of what he is calling the 13th anomaly of this interstellar object. And if the previous anomalies were strange, this one is on a completely different level, because it deals with mathematical precision, so exact that even seasoned orbital mechanics experts are calling it, frankly, unbelievable. This isn't speculation. This isn't interpretation. This is a measurement that simply should not exist in a naturally behaving comet. Right now, 3I Atlas is traveling toward Jupiter, and on March 16th, 2026, it will make its closest approach. That date isn't far away anymore. It's approaching fast, like a countdown. And thanks to over 230 observatories across the Earth feeding their measurements into NASA's Jet Propulsion Laboratory system, we now have an extremely precise prediction of the object's path. According to JPL's refined data, Atlas will pass Jupiter at a distance of approximately 33.21 million miles. But here's where things start getting unsettling. Jupiter doesn't just sit in space pulling things toward it at random. It has what scientists call a Hill radius, an invisible gravitational boundary that tells us where Jupiter's gravity becomes strong enough to dominate over the Sun's. Outside the Hill radius, the Sun is in control. Inside it, Jupiter becomes the ruler, capable of capturing objects. This Hill radius is not some vague concept. It's a mathematically precise number based on Jupiter's mass, the Sun's mass, and their exact orbital distance at a given moment. Loeb calculated Jupiter's Hill radius for March 16th. His result was 33.24 million miles. That means the distance between Atlas's predicted flyby and Jupiter's Hill radius is 35,000 miles. In cosmic terms, that's microscopic. That's less than 0.1% difference. To visualize this, imagine standing at one end of a football field, turning your back to the goalpost, throwing a dart behind you over your shoulder, and hitting within a sliver of the bullseye. Even that would be less impressive than what 3I Atlas is doing. The statistical probability of an interstellar object naturally hitting a trajectory that aligns this closely with Jupiter's Hill radius is around 0.04%. In other words, 1 in 26,000. And this is only the third interstellar object humanity has ever detected. The third object, landing on 1 in 26,000 odds, that's either the greatest coincidence in modern astronomy or a sign that something else is happening here. But things get even stranger. Scientists have confirmed that 3I Atlas has shown non-gravitational acceleration. That means the object is not simply following the predictable pull of the Sun, Jupiter, and other planets. Something is influencing its motion. When astronomers calculated the amount of acceleration, they found a value of 5 times 10 to the -7 astronomical units per day squared. Now, for most people, that number means nothing. But when you translate it into physical distance, that non-gravitational acceleration shifted Atlas's trajectory by around 62,000 miles. And here's the jaw-dropper. That 62,000-mile shift is nearly the exact amount needed to move Atlas from where it was originally going to a path that intersects Jupiter's Hill radius almost perfectly. Not too much of a shift, not too little, almost exactly what was required. Natural outgassing from comets is chaotic. It's messy. It doesn't produce neat, mission-like corrections. It's like shaking a soda can, not performing a controlled maneuver. Yet here, the shift behaved like a fine-tuned adjustment. And the Hill radius is not just some interesting boundary. Right around that distance from Jupiter are the Lagrange points, regions where gravitational forces are so perfectly balanced that spacecraft can park with minimal fuel use. We use these points all the time. The James Webb Space Telescope orbits one. These are strategic cosmic parking spots. So now ask yourself, what are the odds that an object from outside our solar system would accelerate in a way we don't fully understand, shift by nearly the exact required distance, and end up heading straight toward Jupiter's gravitational boundary, right where you'd go if you were intentionally trying to use a Lagrange point? That's why even scientists who normally avoid speculation are starting to sweat a little. They're not saying it's artificial. They're not saying it's designed. But they are saying that the numbers don't behave like anything we've seen from natural bodies. Right now, experts are debating 4 possible explanations. The first is the simplest. Perhaps our calculations are wrong. Maybe the observational data is slightly off. Maybe the models have hidden biases. But in order for this explanation to hold, over 230 observatories, JPL's internal algorithms, independent researchers, and long baseline tracking systems would all have to be wrong in the same direction by the same magnitude. That's possible, but extremely unlikely. The second explanation is natural comet outgassing. Comets often produce jets when ice pockets crack and release gas. However, those jets are random. They depend on rotation, sunlight exposure, surface fractures, things that never produce pinpointed, mathematically perfect adjustments. For Atlas to produce a 62,000-mile correction in exactly the right direction, the jets would need to behave almost intentionally. Nature is incredible, but it doesn't usually act like a guidance system. The third explanation is statistical coincidence. Some astronomers who don't want to stretch beyond familiar physics argue that with enough interstellar objects passing through the solar system over billions of years, eventually one of them might hit a path this precise. But Avi Loeb counters that we've only observed 3 interstellar objects. For the third one to land on a trajectory that rare, that's like buying 3 lottery tickets and hitting the jackpot on the third try. And the fourth explanation, the one scientists whisper about, is that the behavior could be consistent with controlled propulsion. That doesn't mean it is controlled, but the behavior is similar to what you would see if an object adjusted its trajectory intentionally to position itself at a gravitationally efficient location near Jupiter if one wanted to deploy devices, or perform a gravity assist maneuver, or simply stabilize at a Lagrange point. We have no direct evidence of engines, no radio signals, no thermal plumes, nothing that screams technology. But what we do have is numbers. And numbers don't lie. Numbers are telling us something is happening here that doesn't fit comfortably inside our existing models. This is why astronomers are suddenly treating March 16th like a major event, because what happens during that flyby will determine everything. If Atlas sails past Jupiter without slowing down, without curving strangely, without showing additional acceleration, then the explanation is probably coincidence. A weird one, yes, but still coincidence. But if Atlas slows even slightly, if it adjusts its path, if it drifts near the Lagrange regions, if its motion becomes inconsistent with gravity alone, then we are looking at something that no natural comet has ever demonstrated. That would be unprecedented. That would imply either physics we do not understand or something acting with intent, and that's why this matters, regardless of the explanation. If it's coincidence, we've witnessed one of the rarest orbital alignments in the history of astronomy. If it's comet physics we've never seen, then Atlas becomes the most important natural object ever studied. If our calculations are wrong, fixing those errors improves every future mission we send into space. And if it's deliberate, if there is something technological happening, then we are witnessing a moment that will be remembered as long as human history exists. Over the next few weeks, telescopes will tighten their focus. Radio arrays will listen more carefully. Infrared sensors will watch for faint heat patterns. Every movement of this object will be logged, analyzed, debated, and rerun through models, because we are now watching something that may rewrite what we understand about interstellar visitors. And that's why the question keeping scientists awake right now isn't just, what is 3I Atlas? It's, what is it trying to do? For the first time, we have an interstellar object that is not behaving like a passive traveler drifting through our system. It is behaving like something navigating, something adjusting, something approaching Jupiter with a level of precision we simply didn't expect. And that is why, for the first time in this entire investigation, astronomers, physicists, researchers, and even skeptics are all agreeing on one thing. We need to do something about 3I Atlas, not because we expect a threat, not because we expect contact, but because ignoring something this precise, this unusual, this extraordinary would be the biggest scientific mistake we could possibly make. On March 16th, we will get answers, maybe small ones, maybe world-changing ones. But until then, one thing is clear. 3I Atlas is not just passing through, it is doing something. And whatever that something is, humanity needs to pay attention. So, what do you all think about this story? Natural phenomenon, defying our current models, technological artifact from an alien civilization, or something entirely beyond our current framework of understanding? Leave your theories in the comments, and if you want to follow every update in this saga, subscribe to the channel because December 19th, 2025, when 3i Atlas makes its closest approach to Earth, promises to be epic. Additional spectroscopic data should be released before the end of November, and those measurements might give us the definitive answer about outflow speeds and material composition. See you next time.